So we will move on to the next item on the agenda, which is the CNSC Staff Integrated Safety Assessment of Canadian Nuclear Power Plants for 2013, as outlined CMD 14 M45. And also, we will get a presentation by the industry on nuclear safety enhancement. Mark, over to you.
Yes, so a notice of public participation was published on June 9th, inviting the public to comment in writing on this meeting item. On June 17th, the draft report filed by CNSC staff was made available on the CNSC website in both official languages. July 17th was the deadline for filing by interveners. The Commission received 5 written submissions from the public. The President will soon turn the floor to CNSC staff for the presentation. But before opening the floor for questions, the President will invite representatives from the different licensees to give a combined presentation on nuclear safety enhancements, also referred to as Fukushima lessons learned enhancements in our daily lingo, and to provide comments on the report. After a first round of questions, the Commission will go through each written submission that have been filed by the public, and the Commission members will then have a further opportunity to ask questions to CNSC staff and licensees on these submissions. I know that the security ratings are now part of the public document that are filed by CNSC staff. I just wish to remind the members that sensitive questions pertaining to security, if any, will be dealt with confidentially at the end of the question period in a closed session. Representatives from CNSC staff and affected licensees, as necessary, would be invited to join the members in the anteroom as necessary. At this time, there is no such request for a in-camera session. Thank you, Mr. President.
Thank you, Mark. So let's start with CNSC staff presentation. And Dr. Wanskowski, I think the floor is yours.
Thank you very much, Mr. President. Today, CNSC staff have the pleasure to present for information the annual report on CNSC staff integrated safety assessment of Canadian nuclear power plants for 2013. The report, hereafter referred to as the NPP Report, provides a summary of the regulatory oversight and safety performance of Canadian nuclear power plants. Included in the NPP report is also the annual update on the Fukushima Daiichi nuclear accident response, addressing enhancements implemented by the nuclear power industry, and the annual update on the Darlington new build nuclear project. The NPP report will be presented by the directors from the Directorate of Power Reactor Regulation. They are assisted here by directors from the Technical Support Branch, who are available to answer any technical questions the Commission may have. Today's presentation will begin with highlights of the nuclear power industry and station safety performance in 2013. The presentation will continue with details regarding the station safety performance and regulatory developments. Towards the end, the presentation will focus on industry regulatory developments and will close with general remarks. Before I turn the presentation over to the directors, I would like to present the executive summary of the industry safety performance. This summary will provide you with the context for the station-specific highlights, including current challenges the industry is facing. As summarized on this slide, CNSC staff have made the following observations with respect to the safety performance of nuclear power plants in Canada. There were no serious process failures of operating systems at any nuclear power plant that could potentially challenge protective barriers. No member of the Canadian public received a radiation dose above the regulatory limit of 1 millisievert per year. There were no exposure of nuclear energy workers at Canadian nuclear power plants above the regulatory dose limit of 50 millisievert per year. There were no environmental releases from the nuclear power plants above the derived release limits. the severity of injuries and accidents involving workers was minimal. In fact, the overall accident severity rate and the accident frequency for Canadian nuclear power plants remained lower than that of other Canadian industries, including the energy sector. And lastly, all licensees complied with their license conditions concerning Canada's international obligations. I would like to point out here that these positive outcomes were the results of multitude of provisions undertaken by each licensee and are, in general, a reflection of good organizational management and control. This slide summarizes the ratings for the safety and control areas and the integrated plant ratings for the licensees and the industry as a whole. You may recall we have 4 rating categories, namely fully satisfactory, FS, satisfactory, SA, below expectations, BE, and unacceptable, UA. These ratings mean, respectively, that the licensee's programs are either highly effective, effective, marginally ineffective, or ineffective in meeting the safety performance objectives and regulatory requirements. Regarding the overall station safety performance, the integrated plant ratings were fully satisfactory for Darlington and satisfactory for the remaining stations. The station integrated plant ratings are unchanged from the previous year. Across the industry, the average ratings were fully satisfactory for conventional health and safety and security, and satisfactory for the remaining safety and control areas. This is an improvement from last year, where only conventional health and safety was fully satisfactory. Overall, for the stations, 11 safety and control areas were fully satisfactory, and the remainder were satisfactory. This represents an improvement of 2 additional fully satisfactory ratings in comparison to 2012. No safety and control areas were rated as below expectations or unacceptable. This is the same results as in 2012, reflecting CNSC's confidence in the licensee's safety performance during 2013. As indicated on this slide, the nuclear power industry also faced some challenges during 2013. These challenges should not be viewed as questioning the safety of operating reactors, which have attained a very high operational safety record. Rather, these are areas where uncertainty in knowledge exists, and further work, including experimental research, may be required to more accurately confirm adequate safety margins or identify particular safety concerns. Firstly, the industry continued to address CANDU safety issues, and as a result made improvements to their operations. Significant effort is applied in order to resolve most of the remaining issues by the end of 2014. Secondly, to assist with the management of aging reactors, industry initiated the Fuel Channel Life Management Project. The objective of this project is to assure the safe operation of pressure tubes beyond their assumed design life. Another issue that the industry is addressing is preparing for decommissioning of their reactors. Lastly, the nuclear power industry continued to implement improvements to strengthen safety in light of the lessons learned from the 2011 Fukushima Daiichi accident. During 2013, the nuclear industry has performed work that resulted in the closure of the majority of the Fukushima action items and the resolution of site-specific issues. CNSC's commitment to safety and regulatory excellence led to ever-increasing focus on areas which are indicated on this slide. Firstly, increased attention was directed to oversight of aging facilities. The Commission recently approved operation of Pickering's reactors beyond 210,000 equivalent full power hours, requesting enhanced analysis and reporting by OPG, as well as increased monitoring and inspection by CNSC. CNSC is also focusing on oversight of licensees as they prepare units for refurbishment and life extension, and conduct transitioning from operation to safe storage and decommissioning. Secondly, CNSC strives to continuously improve safety of operating facilities through the introduction of modernized regulatory documents and safety standards into operating licenses. Furthermore, in response to the Fukushima Daiichi accident, CNSC requested each licensee to implement safety upgrades to reduce the risk of accidents to as low as practicable. Thirdly, CNSC requested each licensee to improve public protection in the event of an accident. This led to improvements in the areas of accident management and emergency response. In addition, the Commission recently provided direction on the pre-distribution of potassium iodide pills in the vicinity of NPPs. Lastly, CNSC is working on advancing its ability of communicating to the public in a factual and objective manner risk from nuclear accidents. The change from unknown to known may influence public perception of nuclear energy and, as a result, increase public risk tolerance. I will now ask Mr. Peter Corcoran, Director of the Licensing Support and Compliance Monitoring Divisions, to provide background information on the annual NPP report and present the industry benchmarking of safety performance indicators. Peter?
Thank you, Dr. Jankowski. Good morning, Mr. President and members of the Commission. I will provide background information on this NPP report and its format, the public comment process conducted earlier this summer, and information on Canada's nuclear power plants. CNSC staff have established a compliance verification program which lays out the conduct of activities such as surveillance and monitoring by on-site inspectors, inspections, and desktop reviews. The results from this program are used by CNSC staff to determine the safety performance and the ratings that are provided in the NPP report. In calendar year 2013, CNSC staff conducted 142 inspections at NPP sites, and these were led by the 23 inspectors located at our 6 sites. In addition, more than 1,400 findings were derived from CNSC compliance activities and used in determining the ratings for the nuclear power plants. CNSC staff assess the safety performance of licensees using a rating methodology that was established in 2010 and is based upon multiple sources of inputs covering the 14 safety and control areas. The inputs for the assessment include findings extracted from inspections, field rounds, and desktop reviews. These findings come from the assessments conducted by CNSC staff at the specific area level within each of the SCAs. The specific area ratings are then rolled up using a computational method, and in certain cases, there is a need for professional judgment where the final assessment falls near the interface between 2 ratings. This assessment process is conducted for all safety and control areas. The SCA ratings are then combined using weighting factors to give an integrated plant rating, that is, an overall rating for each nuclear power plant. During 2013, CNSC staff presented to the Commission 6 event initial reports for significant events that had occurred at the stations. CNSC staff followed up on the licensee's corrective actions for each of these events and concurred with the actions implemented. CNSC staff are available to provide additional details to the Commission on these events. In 2013, the 2013 NPP report was posted on the CNSC website for public comment, as mentioned earlier, from June 17th to July 17th, 2014. The posting of the NPP report was announced on the CNSC website, through social media, and through the CNSC email list. In addition, advertisements were placed in 14 Canadian newspapers. 5 interventions were received on the report. The comments can be generally categorized as follows: Fukushima response, aging of feeder pipes, public information and disclosure, involvement of the Power Workers Union in joint committees at the nuclear power plants, and collaboration between CNSC staff and staff at the Ontario Ministry of Labour. The majority of comments were in the area of Fukushima response and included topics such as the size of relief valves and the adequacy of technical reviews. These comments will be addressed later in the portion of this presentation dedicated to Fukushima response. After this presentation, CNSC staff are prepared to respond to questions you may have on the comments received through the public consultation process. Many of the comments raised this year were addressed in previous Commission meetings. As this map shows, there are 4 multi-unit plants in Ontario and 1 single-unit plant in each of Quebec and New Brunswick. In 2013, 6 nuclear power plants had operating licenses and operated a total of 19 reactors in Canada. The reactor at Gentilly 2 continued to transition to the safe storage state during the year. At Pickering, Units 2 and 3 remained in safe storage, consistent with previous years, after they were defueled in 2008. The Canadian nuclear power industry continues to provide over 15% of the supply of electricity in Canada. For the province of Ontario, 62.2% of the electricity produced in the province was generated at nuclear power plants. These percentages show the importance of this industry to Canada. There are currently a total of 22 licensed nuclear power reactors in Canada. This graphic depicts the status of each reactor as of 2014. Of the total, and as stated earlier, 19 reactors are operating or have been returned to service, as shown by the blue and green bundles, respectively. And 2 reactors are in a safe storage state, as depicted by the red bundles. The Gentilly 2 station is in transition to a safe storage state following the 2012 decision to end operations. This station is indicated on the slide in yellow and orange. This ends the background section of the presentation. I will now continue with a summary of industry benchmarking for 2013. CNSC began to report on performance comparisons between the Canadian licensees and other national and international organizations a few years ago. The approach has continued to evolve, and comparisons involving 5 performance indicators, some of which are benchmarked, will be presented here today. As shown in this slide, the first comparison is the number of unplanned reactor trips per 7,000 operating hours. I should explain that 7,000 represents the number of operating hours for most nuclear power plants around the world. The data on this slide shows the performance of Canadian nuclear operators in comparison to that of World Association of Nuclear Operators, or WANO. It can be seen that in 2013, the number of reactor trips for Canadian reactors is significantly better. That is lower than the WANO value. Lower than the industry performance target of 0.5 trips per 7,000 operating hours, and it remains lower than the WANO value. The industry trip rate has increased slightly in 2013, but that change was not significant. Overall, the Canadian industry is maintaining a low trip rate. This next figure compares the unplanned capability loss factor for Canada versus WANO values. This factor indicates the percentage of the year when a station is not producing electricity due to unforeseen circumstances, such as maintenance outage extensions, forced outages, and unplanned local reductions. The darker colored regions in the bar graph represent the unplanned capability loss factor. The lighter color regions represent the actual energy production capability, taking into account energy losses due to planned outages. From 2012 to 2013, the UCLF values for Canadian industry increased from 4.5 to 8%. This was due to correspondingly higher values for Pickering Units 1 and 4, Point Lepreau, and Bruce A. There is no international target for this performance indicator. Each licensee establishes their specific target for the year. From 2009 to 2011, the trend in the UCLF for Canadian nuclear power plants had been decreasing, but in 2012 it began to increase. The UCLF for Canadian nuclear power plants remains higher than the WANO value in 2013. The higher UCLF for the Canadian industry in comparison to WANO cannot be attributed to a single cause, and it appears to be the result of the differences in reactor technology and the number of reactors in each of those groups. In all cases, the forced outages and the outage extensions that resulted in an increased UCLF were managed safely and in accordance with regulatory requirements. In this next slide, accident frequency is a measure of the number of reportable injuries resulting in lost time or medical treatment and the number of fatalities at a station per 200,000 person-hours worked. This slide shows the accident frequency for the Canadian nuclear industry in light blue versus other Canadian industries and workplaces. It can be seen that the accident frequency for the Canadian nuclear industry remains very low and lower than other Canadian workplaces. The accident frequency for Canadian nuclear industry decreased in 2013, and it decreased for each licensee. Moreover, the Canadian nuclear industry continues to be a safe industry in terms of the frequency of workplace accidents. Staff also wish to point out that there were no work-related fatalities at nuclear power plants in Canada in 2013. This slide shows the estimated annual dose to the public, which is attributed to both airborne emissions and liquid releases from Canadian nuclear power plants. In 2013, this was well below the 1 millisievert dose limit for members of the public for all Canadian nuclear power plants. In fact, they are approximately 1,000 times lower. Please note that because the doses are very low, we have used a logarithmic scale on the left. Each unit on a logarithmic scale represents a 10-fold increase in the value of the estimated dose. The public dose data confirms that Canadian licensees' programs continue to be effective in protecting the public and the environment from radiological releases. The dose to the public is only a very small fraction of the regulatory dose limit. This next slide shows the distribution of effective doses to workers for 2013 and the 5-year trend. I would like to highlight the fact that in 2013, nearly 84% of the workers at Canadian nuclear power plants received a total effective dose of less than 1 millisievert. In fact, the percentage of workers receiving less than 1 millisievert has increased from 82% in 2012 to nearly 84% in 2013, a testament to the continued effectiveness of the licensee's radiation protection programs. The increase in the percentage of workers receiving low dose values has had an impact on the average effective dose to worker values for the stations. As can be seen in Figure 8 of the NPP report, the value for this indicator decreased for most stations in 2013. I would further like to point out that no worker among the more than 24,000 monitored received a dose exceeding the regulatory dose limit of 50 millisieverts per year in 2013. The radiation protection programs implemented by licensees are protecting workers in the Canadian nuclear power industry and resulting in a lower number of workers in the high dose ranges as shown in this slide. I would like now to turn to the directors of the regulatory program divisions who will present summaries for their respective stations. Mr. Ken Lafreniere, Director of the Bruce Regulatory Program Division, will begin with a summary of the performance for Bruce A and B.
Thank you, Mr. Corcoran. Good morning, Mr. President, members of the Commission. Bruce Power is licensed to operate the Bruce A and B nuclear generating stations, each located on the shores of Lake Huron. Both stations consist of 4 CANDU units. The Bruce A and B facility is the world's largest operating nuclear power facility in terms of gross electrical output. In 2013, at the Bruce site, all 8 units were operational. Bruce Power submitted 2 license renewal applications, 1 for each station. In early 2014, Bruce Power applied for, and the Commission issued an amendment of the license period for both the Bruce A and B operating licenses until May 31st, 2015. This will allow an appropriate level of public participation in the upcoming public hearing process. The relicensing hearings for Bruce A and B are now tentatively scheduled for February 4th or 5th, 2015 for Part 1 and April 14th to 16th, 2015 for Part 2. This table shows the 2013 performance ratings for the safety and control areas for both Bruce A and B. As can be seen, the performance in conventional health and safety and in security at both stations continued to be fully satisfactory as they have been for previous years. Overall, the integrated plant ratings for both Bruce A and B were satisfactory in 2013. I would now like to present Bruce Power's safety performance highlights. The conventional health and safety program implemented at Bruce A and B continues to operate and be rated as fully satisfactory. Both the accident severity rate and the accident frequency remain very low. Bruce Power achieved 15.9 million person hours worked without a lost time injury by the end of 2013. Bruce Power's performance in security continued to be rated fully satisfactory. The licensee has demonstrated effective maintenance of its security facilities and equipment. Bruce Power is also addressing areas of regulatory focus, namely for pressure tube fitness for service, as well as aging of structures, system, and components. All licensees, including Bruce Power, continue to use fitness for service approach to assess aging of major components. This includes maintenance, inspection, and testing of the system, structures, and components. During the reporting period, there were 2 amendments to each of the Bruce A and B licenses. One was for an update of limits according to an environmental standard, and one was an amendment to the license period. A total of 4 revisions were made to the Bruce A License Condition Handbook, and 2 revisions were made to the Bruce B License Condition Handbook. These technical changes involved the addition of new regulatory documents or standards. As an example, the changes to the LCH include revisions to the licensee's action levels. Bruce Power continued to implement the environmental assessment follow-up monitoring program that was approved in 2006 for the Bruce A refurbishment project. This program includes verification of the environmental assessment conclusions, that there have been no significant adverse environmental effects. Specifically, Bruce Power commenced post-refurbishment environmental assessment monitoring. Studies include monitoring the impingement and estrangement of fish species and monitoring for thermal effects with the 4 units now back in operation at Bruce A. The new 37M fuel bundle design is a minor modification to the regular fuel design to improve bundle thermal hydraulic performance. After CNSC staff acceptance, Bruce Power began loading the new 37M fuel into the reactors. The 37M fuel will improve the already significant safety margins of the reactors. This concludes the summary on Bruce A and B. I will now turn over the presentation to Monsieur François Rinfret, Director of the Darlington Regulatory Program Division.
Thank you, Monsieur Lafrenière. Good morning, Mr. President and members of the Commission. Ontario Power Generation is licensed to operate the Darlington nuclear power plant, which consists of 4 units. All 4 units at Darlington were operational in 2013. The Commission hearing for relicensing Darlington was held in December 2012. The Commission renewed the Darlington operating license in March 2013, effective for a 22-month period with an expiry date of December 31st, 2014. The Darlington operating license does not include plant refurbishment activities. The Commission announced that the environmental assessment, or EA, for refurbishment was completed on March 13, 2013. That this decision takes into account mitigating measures identified in the EA screening report and allows the consideration of a license renewal application, which includes both the operating units and refurbishment activities. A renewal application was submitted by OPG in December 2013. However, on June 18, 2014, OPG requested an amendment to its license period for Darlington until December 31, 2015. This amendment would allow OPG sufficient time to provide additional material for the public hearing and to allow the public adequate time to review the additional material. The Commission approved this amendment in July 2014. This table shows the performance ratings for the safety and control areas for Darlington. Operating performance, radiation protection, and conventional health safety continue to be rated as fully satisfactory as they have been for the previous year. The rating for security improved from satisfactory to fully satisfactory. The rating for fitness for service was satisfactory in 2013. Overall, Darlington received an integrated plant rating of fully satisfactory in 2013. Darlington has received this rating consistently for the past 6 years. I'd like to discuss Darlington's safety performance highlights, focusing first on the good practices. Darlington's radiation protection program remained at fully satisfactory in 2013, indicating the licensee had implemented a highly effective program. CNSC staff observed that OPG has implemented ALARA initiatives to even further lower worker exposure. CNSC staff noted positive findings with respect to setting of those targets and monitoring individual exposures. The conventional health and safety program remained at fully satisfactory in 2013. Darlington has significantly reduced the number of lost time injuries as well as the number of lost days due to injury. This has resulted in a reduction in the accident frequency and a significant reduction in the accident severity rate. In the security area, the rating improved in 2013 to fully satisfactory. Darlington staff undertook a variety of activities with respect to equipment modernization, including armored vehicle replacement and radio communications upgrades. OPG has integrated the operation of the Darlington Emergency Response Force and the Durham Regional Police Services in an effort to optimize emergency response. This work was validated during a successful performance testing exercise conducted at the site. In terms of challenges facing the licensee, OPG Corporate has begun the implementation of a center-led matrix organization through their Business Transformation Initiative, or BTI, at both the Darlington and Pickering nuclear power plants. The BTI has resulted in changes to the organization and the management system. Based on review of the OPG top-tier governing documents, CNSC identified that the nuclear management system documentation requires some realignment to reflect the change. CNSC oversight activities have not identified any significant safety deficiencies as a result of the BTI changes. To address aging issues, OPG has implemented at Darlington an integrated aging management program. During 2013, OPG submitted a component condition assessment and an aging management review in preparation for refurbishment. In addition, OPG has updated its life cycle management programs to assure continuous safety throughout the life of the reactors. During the reporting period, the operating license was amended once. The license condition handbook also was revised once. This revision was approved by the Director General of the Directorate of Power Reactor Regulation following the accepted revision process. The changes were primarily administrative in nature. An example of a change to the LCH includes clarification with respect to land use and the Environmental Protection Program. Two initial reports were presented to the Commission during 2013. The first event involved an injury sustained by a contractual worker on January 15, 2013, who was thrown across a trench when an excavated wall collapsed. This occurred at the north end of the Darlington site and did not involve any radiological work or hazards. Details of the event were presented to the Commission in January. This accident did not result in a critical injury to the contractor. The Ministry of Labor investigated this incident, and it was within their jurisdiction. The second event involved smoke coming from an overheated exhaust fan bearing on February 2, 2013. The event report was presented to Commission on May 15 of the same year. The event occurred in the East Fueling Facility. There was no risk to the public, workers, or the environment. CNSC staff accepted the implemented corrective measures. Both events were of low safety significance. In relation to projects and initiatives at the site, I'd like to describe the following. As the Darlington reactor units are approaching the end of their assumed design life, OPG initiated a refurbishment project to prepare for future operation of the plant. CNSC staff completed their assessment of the project, of OPG's integrated safety review, and provided a response to OPG in July 2013. OPG submitted its Global Assessment Report, or GAR, and Integrated Implementation Plan, or IIP, in December 2013. The staff review of the GAR was completed in April 2014. The IIP, however, is currently under review by CNSC staff. OPG has implemented a days-based maintenance project at both Darlington and Pickering to remove non-essential maintenance personnel and activities from a shift configuration. This new configuration has been supported by various validation exercises, which have been independently analyzed by a third party and observed by CNSC staff. Successful analysis provided the basis for amendments to the minimum shift complement. In 2013, OPG continued to refine the minimum shift complement with respect to maintenance staff and emergency response organization personnel. CNSC staff will continue to monitor the implementation of this project as part of its compliance verification program. This concludes the summary on Darlington. I will now turn over the presentation to Mr. Miguel Santini, Director of the Pickering Regulatory Program Division.
Thank you, Mr. Unfred. Good morning. Pickering Nuclear Generating Station consists of 8 reactor units. In 2013, at Pickering, Units 1 and 4 to 8 were operational. Units 2 and 3 were in the safe storage state. Commission hearings for the renewal of the Pickering A and Pickering B operating licenses were held in February and May 2013. OPG had requested a combined single-site license for Pickering for a period of 5 years. In August 2013, the Commission renewed the operating license for Pickering from September 1, 2013 to August 31, 2018. The renewal license included a regulatory hold point that prohibited operation of Pickering Units 5 to 8 beyond the 210,000 equivalent full power hours. To release the hold point, the Commission requested OPG present more information to demonstrate fitness for service for pressure tubes beyond 210,000 hours, and to revise and update the probabilistic safety assessment for Pickering A and B. The hold point removal was considered by the Commission at the hearing held on May 7, 2014. The Commission removed the hold point on June 3, 2014. In its decision, the Commission requested that OPG submit additional information annually on the risk improvement plans and enhancement to the aging management program. The follow-up to these requests will be discussed under the next item in the agenda of this meeting. This table shows the 2013 performance rating for the safety and control areas at Pickering. The performance in radiation protection and in security improved to fully satisfactory. The performance for Pickering in the remaining 12 safety and control areas were satisfactory. Overall, the integrated plant rating for Pickering was satisfactory in 2013, unchanged from the previous year. I would like to discuss Pickering's safety performance highlights, focusing first on the good practices and improvements. OPG has implemented initiatives at Pickering to reduce worker exposure. CNSC staff confirmed compliance with worker dose control requirements through inspections. Overall, the oversight provided by OPG in continuously improving the radiation protection program has been effective in protecting the workers at Pickering. In the security area, Pickering staff undertook a variety of improvement activities, including equipment, procurements, and integration of the safety emergency response force with the local police services. OPG is also addressing a number of areas of regulatory focus for the Pickering NPP. I will not discuss management system and organization, as it was already discussed in the Darlington summary. The regulatory hold point related to the fitness for service of pressure tubes was removed by the Commission in June. One of the factors contributing to this decision was that OPG demonstrated through research analysis and operational experience the fitness for service of the Peugeot 2 beyond the assumed design life. CNSC staff verified this information through assessment and recommended removal of the hull point. The decision authorized the operation of the Pickering units up to 247,000 equivalent full power hours. In preparation for the end of commercial operation scheduled for 2020, OPG is implementing plans to ensure continued safe operation. CNSC is monitoring the activities in this area and are satisfied with the progress made with implementation of the plans. There were no amendments to the Pickering operating license in 2013. Before the amalgamation of the licenses, both Pickering A and the Pickering B license condition handbooks were revised once. After the amalgamation, the new license condition handbook were revised once during the reporting period. The changes made to the LCHs were mainly administrative before license amalgamation and was technical after license amalgamation. An example of change made to the LCH is the modification to the compliance verification criteria to include the role document for the responsible health physicist. The latest revision was to capture the directions from the Commission from the records of proceeding for the whole point hearing. In relation to projects and initiatives at the site, I would like to describe the following. OPG continues with planning and implementing measures to ensure safe operation of the Pickering nuclear power plant to end of commercial operations. The continued operation plan covers the safe operation of Pickering units 5 to 8 in the end of life phase. OPG made good progress in resolving actions related to the COP. The Sustainable Operation Plan is focused on the changes required by the decision to cease operation in 2020. OPG is at approximately the halfway point in the SOP, and it is scheduled to be completed by 2019. CNSC staff are satisfied with the safety and control measures in place and are confident that the end of commercial operation at Pickering will proceed safely. OPG has developed and installed mitigating measures to reduce fish impingement by 80% and offset compensate for entrainment by 80% in accordance with directions from CNSC and advised by the Department of Fisheries and Oceans. OPG has consistently met or bettered the targets. Residual issues remain for OPG to resolve are the specific fish habitat offsetting and the final form of compliance monitoring and reporting. This concludes the summary of Pickering. I will now turn the presentation to Monsieur Ben Poulet, le directeur de la division du programme de réglementation de Gentilly et Point-Lepreau.
Merci, Monsieur Santini. Monsieur le Président, membres de la Commission, bonjour. Gentilly 2 est une centrale à tranche unique de type Candu 600 exploitée par Hydro-Québec. L'exploitation commerciale de la centrale de Gentilly 2 a pris fin le 28 décembre 2012. Le réacteur a alors été mis à l'arrêt et toute production d'énergie électrique a cessé. Tout au long de l'année 2013, la centrale Gentilly 2 a été en transition vers un état de stockage sûr. Le présent permis a été renouvelé en juin 2011 et expire le 30 juin 2016. En mars 2014, Hydro-Québec a demandé à la Commission de modifier le permis de Gentilly 2 afin de prendre en compte l'état du cœur déchargé et le passage à l'état de stockage sûr. La Commission a revu et accepté cette demande et la modification de permis a été complétée le 22 juillet 2014. Ce tableau montre les cotes de rendement attribués à Gentilly 2 pour l'année 2013 pour chacun des domaines de sûreté et de réglementation. Le rendement de Gentilly 2 pour chacun des domaines de sûreté et de réglementation a été jugé satisfaisant. Le rendement global à la centrale a lui aussi été jugé satisfaisant. Je voudrais souligner les points saillants du rendement en matière de sûreté à la centrale de Gentilly 2, en commençant par les bonnes pratiques. En décembre 2012, Hydro-Québec a soumis une analyse de la sûreté portant sur la piscine de stockage du combustible usé et, en 2013, une évaluation des différents scénarios envisagés pour le retrait du combustible du réacteur. Le personnel de la CCSN a examiné l'information soumise et l'a jugée acceptable. Hydro-Québec maintient à Gentilly 2 une force d'intervention composée d'agents de sécurité nucléaire qualifiés et répondant aux exigences du règlement sur la sûreté nucléaire. Cette force d'intervention travaille présentement avec la force d'intervention hors site à la révision du protocole d'entente afin de mieux refléter la situation actuelle en centrale. En ce qui concerne les points saillants en réglementation, il convient de mentionner que des lacunes ont été cernées dans le domaine de la radioprotection. Une inspection du contrôle des risques radiologiques effectuée en 2013 a noté certains aspects nécessitant des améliorations, particulièrement en ce qui concerne la calibration et l'entretien des instruments de radioprotection. Suite à cette inspection, le titulaire de permis a attribué la priorité requise aux mesures correctives touchant la calibration et l'entretien de ces instruments. Le personnel de la CCSN prévoit continuer la surveillance de la mise en œuvre du plan d'amélioration en 2014. Le plan de déclassement de Gentilly 2, élaboré par Hydro-Québec en 2010, ainsi que la garantie financière connexe ne sont plus à jour. Des révisions de ce plan de déclassement et de la garantie financière sont attendues d'ici la fin mars 2015. Le permis d'exploitation de la centrale Gentilly 2 a été renouvelé le 29 juin 2011 pour une période de 5 ans. Aucune modification n'a été apportée au permis d'exploitation ou au manuel des conditions du permis en 2013. Il se vaut de mentionner les points suivants en ce qui a trait à la transition vers un état de stockage sûr et au déclassement éventuel de la centrale. Un protocole administratif, signé le 15 janvier 2013, a mandaté la formation d'un comité de liaison Hydro-Québec-CCSN qui a tenu des réunions régulières tout au long de l'année 2013 pour traiter de questions opérationnelles et réglementaires. Le retrait du combustible du réacteur a débuté le 17 janvier 2013 et a été complété le 3 septembre 2013. Au total, 4 560 grammes de combustible ont été transférés sans incident à la piscine de stockage du combustible usé. Ce combustible sera entreposé dans cette piscine pour une période minimum de 6 ans, suite auquel il sera transféré dans des modules CanStor situés sur le site de Gentilly 2. Le 13 novembre 2013, Hydro-Québec a soumis une demande d'autorisation pour la vidange de la partie haute pression du système de refroidissement d'urgence du cœur. Le personnel de la CCSN a examiné cette demande et l'a approuvée le 9 janvier 2014. La vidange du système du RUC a cependant été provisoirement mise en attente lorsque des concentrations d'eau lourde plus élevées que prévues ont été détectées dans une section de la tuyauterie. Cette découverte n'a eu aucun impact sur la sûreté, mais elle a nécessité une modification de la procédure de vidange. Le personnel de la CCSN est satisfait des mesures prises par Hydro-Québec. Le 4 janvier 2014, Hydro-Québec a débuté la vidange du circuit caloporteur primaire et de ses systèmes auxiliaires selon une procédure qui avait fait l'objet d'un examen de la part du personnel de la CCSN. La vidange de ce circuit est maintenant complétée. En février 2014, Hydro-Québec a soumis le plan d'intervention et les procédures requises pour effectuer la vidange du système du modérateur. La vidange de ce système a débuté en juin 2014 suite à l'approbation du personnel de la CCSN et est maintenant complétée. I will now continue with presenting the Point Lepreau Generating Station Safety Assessment portion of the report. The Point Lepreau nuclear power plant consists of a single CANDU 600 reactor that is operated by the New Brunswick Power Corporation. The Point Lepreau Generating Station was operational throughout 2013. The operating license was renewed in February 2012, and it will expire in June 2017. This table shows the 2013 performance ratings for the safety and control areas at Point Lepreau. The performance for the station in conventional health and safety remained at fully satisfactory, while the remaining safety and control areas were rated as satisfactory. Overall, the integrated plant rating for Point Lepreau was satisfactory, the same as it was in the previous year. I would like to discuss the Point Lepreau safety performance highlights, focusing first on the good practices. The Point Lepreau Conventional Health and Safety Program continues to be rated as fully satisfactory. The accident frequency decreased by 50%. However, the accident severity rate did increase on account of 2 lost time injuries that both occurred during the conduct of training activities. NB Power implemented a full-time industrial fire brigade and continued to train and exercise to enhance performance capabilities in this area. CNSC staff performed enhanced regulatory oversight in this specific area due to performance issues that were identified during some of the earlier drills. In addition to the good practices, New Brunswick Power is also addressing a number of issues of regulatory focus facing the Point Lepreau nuclear generating station. In the areas of fire protection design, CNSC staff continues to monitor the NB Power progress towards compliance with CSA standard N293-07 that is required by December 2014. NB Power has implemented and is maintaining compensatory measures until permanent solutions are fully implemented. Improvements to the fire protection program and its implementation at Point Lepreau are ongoing. To date, NB Power has made a significant investment in upgrades for fire protection at Point Lepreau. CNSC staff will continue to monitor the progress on this issue and will report progress to the Commission before the end of 2014. NB Power informed CNSC staff that implementation of the radiation protection program enhancement in the area of alpha monitoring and control was completed by December 2012. CNSC staff conducted an inspection of this new program in 2013. CNSC staff concluded that the alpha monitoring arrangements had improved, however, noted some deficiencies with the implementation of some of the program requirements. Compensatory measures are in place to ensure worker safety, and NB Power initiated the measures required to ensure full implementation. CNSC staff continues to monitor the progress in this area. One license amendment was made to the Point Lepreau operating license. The amendment was needed due to a company reintegration of the separate operating companies of New Brunswick Power into a single utility. 2 revisions were made by CNSC staff to the License Conditions Handbook during the reporting period. The changes were primarily technical in nature. Examples of the changes made to the LCH include updated information on the 2012 safety report and on the site-specific hazard assessment. In relation to projects and initiatives at the site, I would like to describe the following. In its decision to renew the Point Lepreau license in 2012, the Commission required that NB Power complete a site-specific seismic hazard assessment. NB Power submitted the preliminary results of the site-specific seismic assessment at the end of 2012. By the end of 2014, NB Power will submit to the CNSC the final hazard assessment along with any further evaluations and plans for corrective actions if necessary. NB Power continued to maintain and implement an effective environmental risk assessment and environmental monitoring program with final completion expected by late 2014. In 2013, CNSC staff accepted the NB Power implementation plan to address the results of a gap analysis on the environmental monitoring, noting the need for additional monitoring and documentation. This concludes the Gentilly 2 and Point Lepreau presentations. I will now turn the presentation back to Dr. Chenkowski.
Thank you very much, Mr. Poulet. The next section of the presentation will focus on the progress of industry in regulatory developments. Specifically, the section will provide the annual update on the industry response to the Fukushima Daiichi accident. Also, it will provide the annual update on the new nuclear project being undertaken by OPG at Darlington. Immediately following the Fukushima Daiichi accident, the CNSC task force confirmed that the Canadian NPPs are safe and have a robust design that relies on multiple layers of defense. The design ensures that there will be no impact on the public from external events that are regarded as credible. Nevertheless, the CNSC task force recommended strengthening each layer of defense in depth, built into the Canadian NPP design and licensing philosophy. As of today, all Canadian NPP licensees have made considerable progress in addressing and implementing Fukushima action items at their stations. Specifically, all medium-term Fukushima action items to be completed by the end of 2013 are closed, with the exception of a few related to PSA for external hazard assessment, pending completion of review by CNSC staff. The Canadian nuclear power industry is on track to complete all Fukushima-related enhancements by December 2015 deadline, set forth in the CNSC Integrated Action Plan. Improvements to the design and availability of emergency mitigation equipment are being integrated into licensee systems and programs and monitored through the CNSC's baseline compliance verification activities. In 2013, CNSC staff completed field verification inspections of all equipment installed by licensees, including confirmation of its availability and readiness for use. No issues were identified. I would like to take this opportunity and explain what we mean by saying a Fukushima action is closed. The Fukushima-related actions that were raised were of a generic nature. That means they are applicable to all nuclear facilities. The actions were raised with well-defined deliverables and timelines for their completion, as stated in the CNSC action plan. Additionally, closure criteria and expectations for each action were developed to allow timely completion of improvements. When we speak of closing an action item, what is meant is that the closure criteria have been met. I want to emphasize that closure of a Fukushima action does not necessarily mean full implementation. Verification for each facility is tracked through a station-specific action in a manner consistent with the normal compliance process. To better illustrate this process, let's consider the example of the hydrogen recombiners, or PARs. The related Fukushima action item is now closed for all stations based on acceptable analysis, plans, and timeline submitted by all NPP licensees and accepted by CNSC staff. However, the installation of these PARs is progressing differently for each station. The number of PARs to be installed and their location in the reactor buildings are station-specific and differ from station to station. For Point Lepreau, all PARs were installed before restart during the refurbishment outage. For OPG, PARs installation were completed at Darlington and Pickering in 2014. For Bruce Power, the installation is completed for some units and will be completed at the remaining units during future outages, but no later than December 2015. The table shown in this and the next slide summarizes the improvements applied to enhance the defense in depth of operating NPPs in Canada following the Fukushima Daiichi accident. This is a complete list. The table includes the objective of each level of defense in depth and the corresponding means essential for achieving the key objectives. These means fall into three general categories: design upgrades, guides and procedures, and safety assessments. Each level of defense in depth represents a progression of plant state from normal operation to a severe accident. Level 1 to 3 correspond to design basis accidents, and levels 4 and 5 to beyond design basis accidents. As you can see, reassessment of the design basis accidents conducted by CNSC staff confirmed that all Canadian NPPs are safe. Safety upgrades were recommended for the irradiated fuel base only and are limited to the installation of additional makeup water capability and instrumentation. They are installed already. For beyond design basis accidents, however, significant improvements were recommended to enhance accident protection and mitigation of potential consequences. The list of improvements continues into the next slide and demonstrates a distinct shift in regulatory focus from design basis accident prevention to beyond design basis accident prevention and mitigation. Shown in this slide are the higher level of defense in depth and corresponding enhancements addressing the management of beyond design basis accidents and emergency response. Mitigation of the consequences of accidents has been improved through the introduction of new equipment and procedures and modification to existing systems. It is important to note that two regulatory documents which complement the overall strategy given in this table will be presented to the Commission tomorrow. They are Reg Doc 2.3.2, entitled Accident Management, and Reg Doc 2.10.1, entitled Nuclear Emergency Preparedness and Response. Implementation of these improvements ensures that all Canadian NPPs will shut down and remain in a safe state regardless of the magnitude of any credible external hazard. In an unlikely event of a radiological release, the public will be protected. The ongoing assessment of enhancements to accident prevention indicate that emergency mitigating equipment, which have already been installed, may further reduce the risk estimates for both reactor internal and external events by a factor of 2 to 10, depending on the scenario analyzed. Mitigation of the radiological consequences of potential releases of radioactive material has been improved to ensure that releases caused by severe accidents are kept as low as practicable. As a result, Canadian NPPs are prepared to face the unexpected. The CNSC Task Force recommended steps to further improve public protection through enhanced capabilities for predicting off-site effects and guidelines for protective actions such as sheltering and evacuation. These capabilities were observed during Exercise Unified Response held at Darlington in May 2014. Furthermore, CNSC has determined from its work and assessment that there is a need to pre-distribute potassium iodide pills amongst the residents of nuclear communities. As such, it is requiring license holders to work with provincial emergency management and health officials to both develop and implement local pre-distribution plans by December 2015. Based on the direction from the Commission from the May 7, 2014 hearing, and the results of the study of the consequences of a hypothetical severe nuclear accident, CNSC staff considered to include in the license condition handbook for all licensees compliance verification criteria on the pre-distribution of potassium iodide pills. CNSC staff welcome any guidance from the Commission pertaining to the text given in this slide to ensure that it meets the intention of the Commission. CNSC staff will provide updates on the progress of the implementation of the pre-distribution plans. This task, once completed, will significantly strengthen the last layer of defense in depth against a nuclear accident in Canada. Some of the portable equipment additions and the modification made to reactor systems since 2011 are shown in this slide. As many of the equipment is portable, a memorandum of understanding has been established between OPG and Bruce Power for mutual assistance with respect to emergency mitigating equipment. Similarly, New Brunswick Power has made arrangements with the Department of National Defense at Canadian Force Base Gagetown. I wish to point out that collectively, the industry has committed and spent hundreds of millions of dollars to implement these improvements. There were two major topics raised in the public interventions in the area of the Fukushima response that had been discussed previously for the 2012 NPP report. These two areas have to do with passive autocatalytic recombiners, or PARs, and with pressure relief valve capacity. Regarding PARs, interveners claimed that recombiners are not designed to adequately mitigate combustible gas production from a CANDU reactor severe core damage accident. As communicated on many occasions, CNSC staff concluded from their review that taken with other safety improvements, such as additional coolant makeup provision, PARs are effective for combustible gas, and their installation represents a significant safety improvement. In the area of pressure valve relief capacity, interveners claimed that ASME review of the relief valve capacity issue, conducted in 2014 and posted on the CNSC website, was irrelevant as the capacity of the valves was not included. The Secretariat of ASME confirmed to the CNSC in February 2014 that industry and CNSC staff were correct in their interpretation of the ASME clauses pertaining to relief valves. This reinforces CNSC staff's positions that the bleed condenser relief valve capacity is in fact sufficient. CNSC staff maintain that the issue with respect to PAR's performance and pressure relief valve capacity, which were both fully discussed last year during 2012 NPP report presentation, should be considered closed. Many opportunities were given to the public to comment on the Fukushima Task Force report and the CNSC action plan, as these documents have been through 3 rounds of public consultation. In addition, the public was invited to intervene in front of the Commission at the May 2012 Commission meeting. The current public interventions on this subject did not present any new technical arguments. This is a short update on new builds. The Government of Ontario deferred the Darlington new nuclear project in 2013 because the demand for electricity is lower than previously forecast. OPG is now focused on continuing the collection of information to assist the site-specific design activities to be undertaken after a vendor is selected. In May 2014, the Federal Court released a decision on the judicial review of the environmental assessment and the site license. The assessment is to be returned to the Joint Review Panel for further consideration of its compliance with the Canadian Environmental Assessment Act. This decision has been appealed by various organizations including CNSC. The next slides will summarize the overall concluding remarks on the safety performance of nuclear power plants in Canada and safety improvements being introduced by licensees. Based on all compliance activities, CNSC staff made a number of general conclusions with respect to safety performance of nuclear power plants in Canada in 2013, namely, nuclear power plants operated safely. The integrated plant ratings were determined to be fully satisfactory for Darlington and satisfactory for the remaining stations. All licensees received either satisfactory or fully satisfactory ratings in specific safety and control areas. Licensees are implementing safety enhancements by addressing action items and making continuous improvements to the safe operation of their facilities. The industry is on target to complete all Fukushima actions by December 2015, as per the CNSC Integrated Action Plan. Licensees are completing their work on the safety analysis improvements and the CANDU safety issues. Resolution of the remaining issues is generally expected by the end of 2014. I would like to conclude today by saying that the CNSC staff assessment provides strong assurance that the risk from the operation of nuclear power plants in Canada remains very low. This conclusion is supported by the post-Fukushima safety reviews conducted by the CNSC Fukushima Task Force and nuclear power plant licensees. The implementation of Fukushima-related safety improvements will continue to lower that risk to as low as reasonably practicable. Mr. President and members of the Commission, this concludes the presentation of the CNSC staff Integrated Safety Assessment of Canadian nuclear power plants for 2013. Thank you very much for your attention. CNSC staff is now available to answer any question the Commission member may have. Thank you.
Thank you very much.